Hey guys, want to build a robot? Hey guys, my name's Matt. Now, by day, I'm a high school robotics teacher, but I'm also the founder of ACBR. That's Anyone Can Build Robots, because I believe it. Now, it's my goal that anybody, no matter where you live all around the world, that if you want to learn how to build robots, you should be able to. And that's my goal, and that's why I founded ACBR. And so I started this video series for a couple of reasons. One, for my students. Now, they're trapped home just like a lot of you guys are. And so I wanted a way to kind of capture what we've been doing all in one video. But I also wanted to make this video for anybody around the world who wants to have fun and learn a ton by building robots. And so that's my goal. So in this video, I'm going to show you absolutely everything that you need to build a affordable, really fun and exciting DIY Arduino-based robot. I'm going to cover some tips and tricks, some useful skills, and everything that you'd need to get started. And by the end of it, you'll have something that looks a little bit like this. So I figured the best way to make a video about showing you how to design and build your own robot is going through all of the steps that I took to design one of mine. So here I have the ACBR Rover. I love this little robot. This is actually the same robot I used in my classroom, and all my students love getting to learn how to program this thing. And so when I went about designing this robot, there were a couple things that I did, a couple design decisions that I made to include certain things and not others to make this really, really easy to use. So I think if you're trying to design your own robot for the very first time, or even, if you've built other ones that are less secure, maybe without a circuit board, that this is a really, really great robot to start with. And so I want to make sure that you guys have all the files you need to design and build your own. So in the video description here, I'll have links to the schematic and the PCB and videos of things and links to all the other stuff, just so you guys have everything that you need. I've also got a full 50-page color programming guide for this thing available on the website. And so I just wanted to make sure that you guys have everything you need to have so much fun learning to build robots. What's cool too is if you don't feel like designing your own or sending off to get your own circuit board made, I have these robots available in the shop as a kit, and it has everything you need to get started. Now, like I mentioned before, my whole goal with ACBR was to give away and donate as much robotics equipment to schools and students all around the world as I can. So a major portion of all proceeds go to doing just that. That's really my main goal with this thing. So if you feel like picking up one of our kits, that's awesome. If not, use these files and make your own awesome robot. So I wanted to take a second just to go over some of the details about this robot and the parts that I chose to use, and then I'll show you the process for how we design it. So starting from the bottom, the motors that I'm using here. So these are what are normally called TT motors. I love these black motors here. A lot of times you'll see yellow motors on some of the smaller robots, and these motors are very, very similar. There are a couple differences that I really like about these. One, the gear ratio and the build quality for these is really, really good. I've gotten some other motors in the past, like sometimes you'll see the blue ones that have metal gears, and the gears break a lot, and so I'm using these motors right here. They're just some of my favorites. And what's cool is I have these matching wheels right here. I also included a little bolt to keep the wheel in. Now, that's not always super necessary. The wheels don't come off very often, but without that bolt, they could come off. And so I wanted to make sure that when you're not driving the robot, the wheel doesn't fall off all the time, Okay, also, so I scoured the globe trying to find the best, cheap, strong robot chassis I could, and I was really happy with this one. This one's one of my favorites. So this all-metal robot chassis is really sweet. And what's nice is because they have these 90-degree bends in them already, you only need 2 bolts to attach each motor. So I have these M3 by 25 mil with these nylon locking nuts on here. That means that swapping out these motors if you wanted to is really, really easy. So if for some reason one of them breaks, you can replace just this one TT motor. And you could actually replace it with any TT motor, it doesn't really matter. And it would work just the same. So this chassis is really strong. If your robot drives off the table or something, which happens, that it's not going to break, It's really important. So moving on to the circuit board itself. So you'll see here, I used a couple of M3, these are M3 by 6 millimeter with some standoffs here to attach the circuit board to the chassis itself. So The first thing I want to talk about over here is the power. So I can't stand when you have robots that you buy and you're so excited about, but you have to use their battery packs, that cost a lot, and maybe you want to use a little bit more voltage or some more power, and you don't have that flexibility. And so it was really important to me that you could use, you could get these batteries from anywhere. And so that's why I went with 18650s. So what's nice is, with these 18650s, they're not quite as dangerous as a LiPo. They're not going to catch fire quite as easily. So they're relatively pretty safe. They're also pretty affordable. So if you're willing to get 4 or 5 at a time, you can get them for just a few bucks a piece. And so they're a really, really good battery. So at 4.2 volts, fully charged, gives you 8.4 volts running to these motors with that voltage configuration. Running through this motor driver and these 4 wheels makes for a really, really quick bot. So this guy is surprisingly fast, but also still really safe. And also, I can't stand running robots off of AA's or 9 volts because they get drained so fast. And so, especially in a classroom environment, it stinks to have to change batteries every 10, 15, 20 minutes. And so with these 18650s, you get a ton of runtime. And so that was really important to me to have a rechargeable battery on there. Okay, so the motor driver I'm using. In this robot, I have the L29 3D. Now, admittedly, there are newer, crazier, fancier motor driver chips out there, and they're all awesome. But I love the L29 3D, It's really affordable. It's still really powerful. It's also really easy to understand. So I think if you're starting off with controlling DC motors with an Arduino to build a robot, the L29 3D is an awesome way to start. And so what's nice is because it's small, so it's smaller than, say, the L298, you can have it right here on the board, and it's really clear where it goes, and it makes the process really, really easy. Okay, so any robot needs a brain. In this case, I'm using an Arduino Nano, but this isn't just any Arduino Nano. This is the RFNano, and I love this little chip. So for one, it has a micro USB plug on it, which is really useful. Some of the older Arduino Nanos have the it's USB Mini, and it's just kind of old school, And so what's nice is everyone has micro USB cables lying around, and so it just makes it easier to program. But also, this Arduino Nano has the NRF24L01 radio built in. There are tons of ways to make your robot wireless, and I want to have tons of tutorials about how to do that. And what's cool is if you wanted to, say, use Bluetooth, you can use a Bluetooth receiver using this breadboard and wire it into the Arduino super easily. But if you wanted to build your own radio robot controller, it's super easy. So you could make this robot wireless without any extra hardware because it has that radio built in. And so I've got a tutorial video coming up here pretty soon about how to make your own wireless controller, because it's really fun if you haven't ever tried. Okay, also, let's see here. So if you look right here, I've got this little diode, and this is for reverse battery protection. The forward voltage of this is really, really, really low, talking 0.1 volt or something. So what's nice is it protects the whole system but doesn't drop the overall voltage, so you still get plenty of speed. And so that's there. If you look here, I have the positive and negative of the battery on the circuit board. What I found is it's just necessary to have that extra level of protection. Sometimes you're having fun building robots, and it stinks to plug one of the batteries in backwards and the whole thing fries when you were just having fun using that robot. And so I have that protection in there just to make it a little easier. I've also got a power switch on here, right? This little power switch is useful. That way you can turn the robot off without having to pull out the batteries. Okay, now going towards the front of the robot, I wanted to talk about this breadboard right here. So I love these little mini breadboards. It's the exact same size as a standard mini breadboard. And the black color, obviously, I wanted to match and look nice. And so what's cool about this is if you notice, I have all of the pins of the Arduino broken out to a second set of headers. So there's a set of header pins on either side. And so what that means is I can plug anything into here and wire it straight into the Arduino super easily. So we're talking lights, or you wanted to add some sound, or you want to have any kind of a sensor, There's tons and tons and tons of options, and so I have tons of examples of stuff that I do with my kids in my classroom, and I want to have a bunch of tutorials on the blog about all the crazy stuff you can add to this. So the last thing here we have is the JST connectors, and so I love these JST connectors. Obviously, if you plug a DC motor in backwards, it's not going to break, it's just going to flip the direction it's spinning. But if you have your code set up and you have 8 of these wires and you can't remember which ones were which, if you're using regular like DuPont wires or even if you solder them in, sometimes they can get pulled out, and then you have to resolder it, and that can be kind of a pain in the butt. And so what I found is that these JST connectors are awesome. They make it so that if you set up your code once, that you know your motors are going to be spinning in the right way. But also, too, since they have a little bit of a click to them, if you're going over rough terrain, they're not going to pop off. So they're really useful little motors, little connectors here. So those are essentially the features of this little bot. And what's cool too is you can take our design files and you can make your own. There's tons of cool stuff you can do with this. So enough about this robot. Let me show you how you can design one of your own.
Alright, so the first step in designing our robot is going to be figuring out our wiring diagram. So one thing that's so cool about building robots with Arduino is to get a robot started, you really don't need too much. And so here we have our motor driver IC chip, the L29-3D, as well as our Arduino Nano. So obviously our end result is not going to be on a breadboard. We're going to design a circuit board to house all the wires for us. But this is a really awesome first step. And so you can learn a lot and have a lot of fun building your circuits on breadboards first. And this will be a really good opportunity to talk a little bit more in detail about what all these pins of the L29-3D do. So even though there are 16 pins on this chip, and that can seem like a lot, if you break down what each one of them do individually, you can actually break it down to a pretty easy level. And so that's my first goal here. And so whenever you have an L29-3D like this, I always ask my students to wire from the middle. And the reason we want to do that is that this chip is incredibly symmetrical. And what's cool is if we look at the middle 4 pins, they're actually all ground pins. So whenever we're talking about robotics, electronics, engineering, we refer to our negative, and our circuit is ground. And so every circuit ever needs a positive, negative. Usually when you're dealing with an Arduino is 5 volts and ground. So in this case, our very first step is going to be connecting all of our grounds together. And so if we notice right here, there's also a ground pin on the Arduino. And so that's going to be really important to get connected. So my first step here is just going to be connecting my grounds together. Okay, so now thanks to the magic of the breadboard, if I plug my wire in here, I've got a connection here, I've got my grounds connected, we've got all 4 of those right there. So that's 4 out of the 16 taken care of. So the next things that I usually wire when I'm dealing with the L29-3D are the motors. Because what's cool is, if we look right here, I have a pin that's called output 1 and output 2. And that refers to the voltage that'll be sent out to the motors. And so if I grab a DC motor, now obviously this motor looks a little bit different than the ones that we're going to be working with, but a DC motor is a DC motor. So if I grab this DC motor right here, I'm going to want to wire this on either side of ground. And what's cool is because this chip is so symmetrical, I can do the exact same thing on the other side. And so if I grab this motor here, I can drag this guy over here. And do the exact same. I'm going to drag this one out like this. Perfect. Okay, so we now have 8 of the 16 pins taken care of. The 4 middle pins going to ground, and working our way out, we have the 2 wires of the DC motor on both sides. So the next thing we're going to want to wire up are the positive pins. And so one thing that's really cool about the L29-3D is that there are 2 positive voltage spots. So one is right here. So in the upper left hand corner we have the main VCC. So this is to power up the chip itself. And what's cool is this chip only needs about 5 volts to power itself to start thinking. But there's this second positive voltage pin, and that's right here in the opposite corner. And so that positive pin is for sending voltage straight to our motors. And so even though the L29-3D only needs 5 volts to power up, what's cool is we're not limited to 5 volts, because if we weren't able to give this thing ever more than 5 volts, it'd be kind of lame, because the speed of our DC motor is proportional to the voltage it's receiving. And so if we were limited, that would mean that our robot was really slow. And so having this extra voltage pin is super useful. That's what we're going to plug our 18650s directly into here in a second. Now for this example, I'm just going to use 5 volts just to make it easy, just to show you guys where the positive power pins go. But keep in mind there are 2 and they do have different jobs. So let's see, I'm going to put positive power to my top pin right there. And I'm going to go ahead and wire my positive power from this side over here. Okay, so now I have my positive, positive, negative, 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 negative. I have my motor wired up. And so what's cool is there are only 6 pins left that we haven't wired up. So there are the opposite corners that we still have here, and then there are pins on either side of the motors that we haven't used yet. And so these pins all have very, very important jobs. And so we're going to go through and wire these up now. The first thing I want to talk about is how to control the speed of these DC motors. So if we look at this bottom left pin, we'll see it says enable 1. Now the enable pin is how we control speed for this half of the chip. And what's cool is if I go with the other side here, enable 2, the opposite side, controls the speed for this half of the chip. And so it makes it really, really easy. Now, in order to control the speed, we need what's called a PWM signal. That's pulse width modulation. So that just means the frequency that we need to send out to control its speed. And so that means that we need to use a PWM pin on the Arduino. Now, on the Arduino Nano and the Arduino Uno, they're the exact same. So if you look right here, there's a little asterisk here. And on the Arduino Uno, it's a little squiggly line. But I have pins 3, 5, 6, 9, 10, and 11. Those are all PWM capable pins. And so those are going to be the pins that I need to choose from to control the speed of my motors. And so you could use any of them. But for this example, what I'm going to do is I'm going to use pin 3 to control the speed of this half of the motor here. Let's go ahead and give that a different color. All right, blue. So here I have pin 3 of my Arduino plugged in to control my speed. Now, this pin right here, this is input 1 and input 2. Now, the input pins control the output pins. And I mean, that sounds kind of simple, but it's well designed. And so if I wanted 5 volts to go here and make my motor spin in a certain direction, that's controlled by the input. So if there's 5 volts on the input pin, then there's 5 volts on that output pin. And same for the other side. So if I have 5 volts on input 2, then I'd have 5 volts going out of output 2. And so it's in that way that we can control the direction. So it's all about hooking up my input pins to the Arduino and turning those on and off. And so again, this is something I cover in way more detail in the programming guide. And again, that's like that 50-page PDF I've got on the website. So feel free to check that out if you want a little bit more information on that. But I'm going to go ahead and wire up my input pins on the L29-3D to pins 3, 4, and 5. So 3 being the PWM pin, 4 and 5 being my direction pins. And so I just like to keep those nice in a row because it makes it organized. Really, there's no other reason than that. And so now we're going to wire up the second half of the chip. So for my second enable pin, I still need a PWM pin. But if you look, the next pin I have open in this line is pin 6, which is a PWM pin. And so let's go ahead and use that for our enable pins. Okay, so now I've got enable 2 plugged into pin D6. And so all that's left are the direction pins for that second half of the motor. And so to keep this nice and organized, we're going to go ahead and use 7 and 8. Now, admittedly, this circuit looks a lot crazier than it did a few seconds ago. But if you go step by step, it's pretty straightforward in terms of how this thing operates. Now, this is just our wiring diagram. So this is just a representation of if you were to physically build this circuit with wires, what it might look like. But we're going to see that in a second. Before we make a circuit board, we're going to need to create what's called a schematic. And so that's what we'll go ahead and we'll do here in this next step. All right, so here we have our full schematic. And so this is based on that wiring diagram we did before, but you can see that this format is a little bit different. So the program I'm using here is called Easy EDA. I love this program. It's super easy to use to build schematics, and it's also what I use to build all my PCBs. It's a really awesome program. It's free. It's easy to use. Honestly, I can't say enough good things about it. There are crazier circuit board design programs out there. Absolutely, there's some great ones. But this one has a lot of features, and it's really easy to use. And so I'm going to use it here to show you guys how to turn that wiring diagram into an actual PCB. Okay, so first things first, this is our L29-3D. Now, this obviously is not a picture, but if you see, the pins are all the exact same. So we have the voltage that goes to our motors. We have the voltage that's needed to just power up our pin. We have our ground pins. And so you'll notice I don't have any wires here. I'm using what are called flags. And so this ground flag is actually attached to ground. You see, I've got this wire right here going to ground. And this way of making your schematics is just really, really easy. It keeps it really nice and organized. It just makes it a lot easier. So I have my Arduino Nano right over here. I have the L29-3D, and I have all of the exact same wiring. So if you see here, I have enable 1 going to pin D3. Just like we did in the wiring before. This just looks a little bit more organized. Now, I've also included an extra set of headers. Like we saw before, we use those to wire up things to the breadboard. Okay, so if we go right over here, I have my 18650s. Okay, so these right here are my two 18650 batteries. This is that Schottky diode for the reverse battery protection. Like I said, the forward voltage of this thing is pretty low, so it still makes for a quick little robot. Okay, here I've added in a power switch. That's something that I didn't put in the wiring diagram for obvious reasons. It's just easier. So I've got a power switch right here to power the whole thing. And lastly, I have my JST connectors. So if you look right here, I have output A2, output A1. Output A2, output A1. Those are going right here. Output A1, output 1. Output A2, output 2. And so if you notice these two motors, I have two motors hooked up here, or two little JST connectors, and they're just wired in parallel. So the right half of our robot and the left half of our robot, even though they're two motors, they're essentially just wired in parallel together. Now, obviously, you can pick way too big of a motor, or you can hook up way too many motors, and your amperage is too much for your motor driver to handle. But what's cool is wiring up a second motor, so you have two per side, is really, really easy. And so you can see that they're connected to the output pins just like we had in the wiring diagram before. So again, I'm going to post a link to this schematic on the blog post, also on this YouTube video here. So so you have this for you. So what's really cool is even if you take this exact schematic, you can create a whole different PCB. You can also add to this and change it around and do whatever you want. This is just a really good bare bones setup. And so what's extra cool is if you want to convert this to a PCB, which is our whole goal, it's really straightforward. So if you create an account with Easy EDA, you have this button right up here. It's called Convert to PCB. So if I click this right here, ask you if you check your connections here. I don't, because I'm not using every pin. So it'll say, oh, this pin's not connected, when I did that on purpose. And so I say, no, keep going. Got to save that file. Okay. And then we got a window that looks just like this. So that purple background, that's actually the outline of your circuit board. And so if you see, this actually populates all of this stuff right down here. And so if you were to go back and look at our robot, we'd see that we now have actual physical representation of all the stuff that we had before. So this is our Arduino. We've got one of our batteries right here. We've got a second battery right here. This is our row of header pins. Rotate that around. And we've got the other set of header pins. The L29-3D. Got our power switch. Put that sucker right back here. We've got our diode. Had that right there. This is one of our JST connectors here. We can see that these with these blue lines are attached right here. So I have our other JST connector right here. This guy right here. Put that JST connector right here. Okay, so I'm gonna go ahead and design this board and fast forward a little bit. Again, I'm gonna have this completed board posted with a link. So I think the best way to figure out how this thing works is to actually open up the file, look around. I'll pause every so often to show you guys a couple important things here. But other than that, it's super fun. So if I wanted to start with my very first wire, maybe I'll do that. So we can look at this positive wire right here. So red indicates the top of the circuit board. Blue is the bottom layer. So if I go to the top layer, I can click on this track and I can draw a trace. One thing that's really cool too is it automatically has these nice 45-degree angles for you. And there are some tools in here that make this really, really easy. So you see how this wire is kind of wonky here. What I can do is drag that wire and it will automatically make this really, really nice and organized for me. So I can even make this into a 45 like that and keep this super organized. And you might notice too that because this is a positive, the positive side of our battery, this wire is actually pretty small. So if I wanted to make this a larger size, I could absolutely do so. So let's see here. So there I've made this a little bit bigger. Now in reality, I'm gonna pour some copper that will make this whole thing really, really easy and make our thermals really nice here. Okay, so I'm gonna go ahead and speed this sucker up and design this board and then we'll talk about it. All right. Okay, so we have all of our traces routed for our robot. Now, you may notice that the version that I post has things like logos and things are moved around a little bit and minor changes here or there. I didn't want to take the time to do the entire thing. I just wanted to show you what it could look like. Now, there are an infinite number of ways you could wire this thing up, but this service, Easy EDA, makes it so easy. So before I show you the final step, I wanted to show you something that I think is really, really, really important here. And so right now, if I were to wire this up, I would actually probably change the thickness of some of these wires and move things around a lot here, but that would take quite a while here. Okay, so what I want to show you here is adding a copper area. So this can be really important for managing heat. And so if you click on this copper area, you'll see that you have an option to tie it to a certain connection. Now in this case, we use ground. So on the bottom layer here, I'm going to click around my circuit board. And once I hit escape, you'll see that it's actually connected all of these ground connections and made one big ground plate, which is really, 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 really helpful. And what's cool is you can actually do the same for the top. So the top, I'm going to not use ground because I already did that here, but I'm going to go ahead and use the 5-volt line. I'm going to do the exact same thing for the top. Just make a square around your circuit board. This doesn't need to be super neat, because it's not going to make anything that's bigger than your circuit board. Okay, perfect. So now you see we have a really nice professional looking board with our copper planes there. And this is starting to look pretty good. So the last thing I would do is add holes and things. I won't waste your time doing that right now, but it's really easy here. So if I wanted to add a hole right here, all you need to do is click it right here. So you can control make the size bigger and things like that. So the holes that I have on the circuit board are the ones that match my chassis. If you wanted to use this to build a different one, you totally could. It is not too tricky here. But yeah, so this file will be posted. If you want to edit it, you can leave it the way it is. You can pick one of them up from us. The possibilities are endless. So we are on our way to having a circuit board. So once you're satisfied with your circuit board, you want to save it here. You can actually export to what's called a Gerber file. And so this is how you get your circuit board manufactured. One of the things that's so cool about Easy EDA is it makes this really easy. So if you press this little G button right here, you can generate a Gerber file. So you see, this is what your circuit board would look like. You can download that Gerber file, or you can actually export it directly to what's called JLC PCB. They are awesome circuit board manufacturers. They're who I use for all of my circuit boards, and I can't say enough good things about them either. So really fast. You can get a turnaround in just like 2 or 3 days. Usually it takes only about a day for them to make the circuit board. And if you use DHL shipping, you can get your circuit board within 3 or 4 days from that. So it's super quick, and it's also really, really affordable here. So I'm not going to show you how to do that right now because it's not really important. But you can generate the Gerber. You could also take it to a different company to manufacture your board. But that is the file that you need to take this into, to turn this into a physical circuit board. So with that, we are ready to grab our circuit board and solder it up. All right, let's solder this thing up. So if you end up picking up one of our kits, you'll notice that I have the diode already soldered on there. It's not too tiny of a component, but I just want to make this easy on people, so I'm going to skip that part right now. But if you're soldering this thing up as a kit, the first thing I like to start with is the L29-3D socket. So you could, in theory, solder that L29-3D straight into the board. But I find it's helpful with if you have this socket on here. One, you're not applying tons of heat directly to the chip, but also just in case something went wrong or you wanted to swap it out or use it for a different project, you could. So putting it in there, it's not too tough. Just want to make sure you line up all those holes. Get it in right there. And I like to put that semicircular cutout facing the front. Now for the socket, it really doesn't matter, but I like to keep it consistent. And so the reason I like to start with this component first is it's right in the middle. And one thing I like to do just to be extra safe is solder in just these top corners right here. And then I can make sure that the socket is nice and flat on there and it looks like it is good to go. It's not lifting off. Looks nice and straight. And so if everything looks good, go ahead and solder up the rest of the pins. Okay, looking good. Next, what I like to solder up is the socket for the Arduino Nano. So it's really important that you have all of these pins line up nice and straight. And so what I like to do here is put all 4 pins in at once. Put all 4 pins in there and then just kind of slide it on the table. And so it's going to lift up. If you have somebody to solder with you, this can be super, super helpful. But it's also not impossible to do by yourself. So what I like to do is I'll put my finger down, give a little bit of pressure, so that way the pins come out here. And then I'll solder in just the top pins. And so one of the reasons why I want to solder in just those top pins first is I really want to make sure that it's nice and straight. So if your board, if all these header pins look nice and straight, then you are good to go. Once you're confident that they're not lifting up or that there's no issues, you can go ahead and solder in the rest. All right, looks like we're good to go. We've got our header pins for the Arduino Nano socket all soldered in. Next, we'll go ahead and solder in our power switch. Now, this doesn't really matter which way it goes, but the spot for that power switch is right here. And this is another one that can be kind of tricky if you're soldering by yourself. What I like to do is kind of similar to the other pins. What I like to do is solder in just one of the pins. You can see I kind of have this solder over here. So if you solder in just one of those pins, you see it's obviously pretty crooked on there. But if you only have one of the pins soldered in, what you can do is heat that pin back up, make sure it's nice and straight, then let it solidify. And then we have this on here nice and straight and we're good to go. So again, I love having someone helping me out when I'm building these boards. And like in my classroom, I always have my students build these boards in too, but it is not impossible to do yourself. Okay, power switch soldered in. All right, next component we have are the JST connectors. So you'll notice the JST connectors, they have one side that has a cutout on it and the other side is flat. And so you want to make sure that you have the cutouts facing inward on all of these. Okay, JST sockets plugged in. All right, so last but certainly not least, we have the battery holders for our 18650s. Now there is, if you notice on here, there is a positive and negative on these. I have it printed on the board, so it's not like it's not going to work if you put the socket in backwards, but it is helpful, you know, if you want to make sure that you have the positive side over there. So in this case, I have the positive side right here. And now I made these pads a little bit longer, and that was just to make it easier to solder in. So it's really pretty easy. And don't worry about using too much solder because it's not a big deal. All right, and so with that, these boards are soldered up. Now let's see, let's go ahead and add our extra components. So we have our Arduino Nano with the NRF24L01. So it's really important that we have the USB facing this way, towards the back. Obviously, if we have all the pins in backwards, then it is not gonna work. All right, so you get that sucker plugged in right like there. And then we have our L29-3D. So look, if you look, there's a little semicircular cutout right here. It's really, really important that it faces the front. I mean, otherwise it's just not gonna work. Okay, so when you're putting these pins in, it is really easy to bend these as you're pushing it in. So when you place these chips in their sockets, you really wanna make sure that you don't bend any of them. Once you've got everything lined up, clip it into place. All right, our final step is the breadboard. So like I was saying earlier, I really like these little mini black breadboards. All you have to do is take off the adhesive backing here and put it in front. And just like that, we have our Rover complete. Next, we'll bolt it to the chassis and we'll get this thing rolling. All right, now that we have our circuit board all soldered up, turn it on. If we got that red light, that means we are good to go. That means everything is working just like we want it to. All right, so it is time to attach the circuit board to the chassis. And so this really isn't too tricky, but you do have to do things in a very certain order, and that's really, really important. So the first thing you're gonna wanna do is find these 6mm M3s. I have these nylon 6mm M3s, and the next thing you want to do is find your standoffs. So in total, you should have 8 of those small screws and 4 of these standoffs, because these standoffs are going to be what we use to attach the circuit board to the chassis. All right, so step number 1, take one of those small nylon bolts and stick it right in here. Then you'll want to make sure that these go on there. Now you don't want these all the way tight yet, so I've got a little bit of a gap there. That's going to be pretty important. It just makes it easier to fit on the circuit board later. But you're going to want to do the exact same thing for all 4 corners. Okay, once you've got the standoffs in the 4 corners like that, you are ready to attach your board. So I usually like to go just 1 bolt at a time here. Now, the only thing that's important about this is you have your side here with the JST connectors. You're going to want to make sure that's on this side with that circle. It's not impossible if it's the other way. It's just that is where it'll make it easier to put the wires through. And so you'll want to line up that first piece. And once again, I wouldn't get it all the way in. You want to make sure there's a little bit of a gap there, just because that'll make the whole thing easier. We're going to get all 4 of these things in first, and then tighten the whole thing up. Okay, we have all 4 of these in, and once you have them all set and on all 8 of those in, you're going to want to make sure to tighten the whole thing up. All right, that robot's not going anywhere. Okay, so now that we have our circuit board firmly attached to the chassis, it is time for the motors. So like I mentioned before, I love these black TT motors. They're really, really useful. So if you were to order one of our kits, they come zip tied and pre-soldered for you. In case you were trying to do this yourself, if you want your code to match what we have, then you're gonna make sure that you have, with the shaft facing the left, the red wire on top and the black wire on the bottom, and that'll be the same on all those. But if you have one of our kits, you don't have to worry about that because I did all that for you. Okay, so like we said before, it is really easy to bolt in these motors. What's sick is you only need 2 bolts per motor there. So these are M3 by 25mm, and they fit perfectly all the way through here and then right through that motor. But keep in mind, there are also 4 of these, and these look very, very similar. This is actually not metric. This is a number 4. It's a number 4 self-tapping screw by 1 inch. And this is what we use to attach the wheels to the motor, just to make sure there's a little bit of extra security. So another thing to keep in mind too is you want to make sure that the wires are facing inside. That's going to be really important. Now, it doesn't matter which motors go where, because they're all the same and they all have the same wiring. But you just want to make sure that you're not grabbing any of the screws, because they look similar to those bolts, but they will not work. Another thing that's really, really helpful is I included these nylon locking nuts in my design, because I've found that these motors are pretty good at rattling themselves loose. And so they can be a little bit tricky to start. So you see how I started that with my finger? What you want to do is you can go ahead and start them, and then the second you hit that nylon ring where it gets a little bit tough, stop there. And then you can do the bottom 1, 2. I've just found this is easier if you start it off with your fingers. Okay, now, even though these can be kind of a pain in the butt to get started, they're really, really strong, and what's nice is they'll stay nice and secure. So I also include this 3D printed M3 wrench. And that makes it really, really easy. And so I've got this little mini screwdriver that comes with the kit too, just to make it easier. That was my whole goal with this robot, is just to make this so easy that anybody can do this. So you see I just put the wrench on there and then tightened it up a little more. Get that out of the way. And so, with the help of the wrench and this little screwdriver, it's really, really easy. And so you'll do all 4 of these motors the exact same way. Okay, motors are attached. So in order to wire these things up, you want to make sure that you have your right motors together and your left motors together. And so here, this I have will be the left side, and so you're going to want to feed it right through here. And you'll plug those in. Right here. Same for the other side. And you don't have to do these right side to left side. I've just found that it's easier to make sure you don't get confused. Because if you have the motors plugged in the wrong spots, your robot will be spinning around when you want it to go straight. Okay, we've got these plugged in. So now it is time for the wheels. So you see these are right here. We have these holes here. And these motors don't actually come with holes in them. I drill these in just because I found that they fall off sometimes. Now if you have those yellow TT motors, they don't fall off quite as often, but they're still really good wheels. And so if you are curious, I've found that a 7/64 bit, if you drill that through, and you use this number 4 by 1 inch screw, that it's perfect. And so you'll screw in all of your wheels just like this one. All right, now that we have our motors bolted in, the wheels attached, everything connected, this little guy is complete. All that's left now is to test it.
Thanks so much for watching, guys. We hope you enjoyed this video, and I hope that this helps you on your journey to having a blast building robots. If you're looking for more information or other tutorials, feel free to head over to anyonecanbuildrobots.com. We've got tons of stuff that we're adding all the time. Thanks again for watching. Have a great day, and remember, anyone can build robots.